Hi, everybody. This is the walkthrough video for Tuesday. It is April 15th. We're back together in in-person school. This is a new yellow bell work. It's a big one, so you have a space to write and draw this week. It's page 37. Okay, so what you're going to do here is, let me get rid of all this mess. What you're going to do here is write these phrases down, and then you're going to use any letter to give these genotypes, these two-letter combinations of a living thing. And then you're going to circle the ones that give a dominant phenotype. That's going to help us in our work today. So today we're going to try to figure out how scientists study whether evolution is actually happening. So you're going to review a math routine for finding out. You're not going to need to do this type of math in our exam. In fact, we literally took a question off that's stuck in there, but it's going to be a good review for you. So today's assignment is called Amoeba Sisters Hardy-Weinberg Equilibrium. Let's go ahead and update your table of contents page. If I scroll all the way down here, you'll be able to see we had 2 new entries, plus an important note, which is that the Unit 5 study guide and vocab, completing those assignments and turning it in counts as the week 7 quiz. And you'll see that updating in just a little bit in the gradebook. All right, do you remember these? Hopefully you remembered those. And we want to remember that although all those other things happen, none of those lead to adaptations. Adaptations are those traits that we know have a positive impact. And so natural selection are the traits that have, that said positive impact, but they're beneficial in a given environment to an organism. And ones with those are better able to survive and reproduce, right? So those 5 mechanisms of evolution. We haven't talked about yet is how we actually know if any of these things are happening. And so what we're going to do back today is think about the genotypes and the alleles. So the answer to the question of like, how do we know if any of these things are happening is that we look to see if the frequency, remember that's percentage in decimal format, of genotypes change over time. If there are changes in the genotypes, then we know that either mutations are happening or living things are coming into that population or leaving the population. Natural selection is at work. Random chance is happening, things like that. So today's work are these 2 things. I wanted to help you. The Hardy-Weinberg equilibrium assignment looks like this. These are the 5 fingers of evolution. So you just have to write no blank, no blank, no blank, blank population, and blank mating. Now, these are the things that, these are the opposite of the 5 fingers. So each one of those is going to be the opposite of those 5 things. Cool. Okay. And then it's going to get to the point in time in this assignment where you're going to write stuff down, and I want you to write these things down. So when it gets to those pictures, please write this text, please write that text, and then this text for the froggos. So that text is going here. For 14, it's the information on top, and for 15, it's the information on the bottom. If this is hard to see, you can always go to today's date in Canvas and click it. It'll take you to this document. Now, this is the last question that's here. It says, in a species of frogs. I just wanted to walk you through this. So it's different from the one in the video, but the procedure you follow is the same. So it says here, it tells you that 88% of the frogs are dark green. So I'm writing here 0.88. And then it turns out that you can also know what frequency of frogs are light green because 100% is $1 worth, right? And so 1 minus the frequency of the dark green frogs, that percentage, gives you the frequency of light green frogs. So indeed, when we take 1 and we subtract 88, you get the frequency of light green frogs, and that's 0.12. That is Q squared. So once you've watched the video, you'll be able to see that you're going to move through the assignment and try your best using Q squared to find Q by taking the square root. And if you find Q, you can find P. And by doing that, you can do these and answer the questions that are on that worksheet. Again, won't have to do that outside of class, but pretty helpful. Okay, this is important because we have not done a great job of reading these to you, and I want to make sure that you know about them. So this one is, I'm going to have to do the whole thing. I'm not going to do that. So this one is homologous structures. Those are body parts in different organisms that come from a recent common ancestor. And analogous structures evolve separately. Remember that homo means same, like homozygous dominant or homozygous recessive. And it might help you to think about analogies. Those are where we use like or as, but they're not the same thing. So that might help you remember those ideas about homologous structures and analogous structures. All right, that's it for me. I hope you're doing well out there. See you soon.